Hello children. In this class also we will continue arithmetic progression. Topic 8 problems on S and formula continued. The first one in this class is this: if the sum of the first n terms of an AP is 4n minus n squared. So this can be written by using Sn notation as Sn equal to 4n minus n square. That is the meaning of sum of the first n terms, 4n minus n square. Now we shall take sum number 1. What is the sum of first term? Sn means a1 plus a2 plus a3 plus etc. plus an. S1, that is sum of the first term. Therefore, S1, this is the meaning of sum of first term. Sum of first term. Okay. Then in place of n, let us substitute 1 minus 1 square equal to 4 minus 1 equal to 3. So this is what the sum of first term. Okay. So this is sum number 1. Next, the second sum is this. What is the sum of the first two terms? Yes, children. How do you denote this sum of first two terms? Yes, it is by S2. Therefore, and S2 equal to, take the same given nth term, sum of n terms, S notation. S2 equal to 4 into 2 minus 2 square. 4 2s are 8. 8 minus 2 is, 2 square is 4. 8 minus 4 is what? 4. So thus the sum of first two terms is 4. Next, look at the third sub number. Find the first, second, third, 10 and nth terms. So therefore now, with the help of this S1 and S2, we shall try to find out this first, second and so on. Now, the third one is this: find the first, second, third, 10th and nth terms. Now therefore, after finding S1, what is the meaning of S1? S1 is nothing but what? Sum of first term. Therefore, children, now A1 is nothing but S1. What is S1? Sum of one term. Therefore, it is A1. Hence, the first term A1 is S1. That means it is 3. Next, second term. What is the second term? And A1 plus A2 equal to S2. Correct? Okay. S2 is nothing but what? S2 equal to A1 plus A2. Therefore, here we can write like this: A1 plus A2 equal to S2. Therefore, A1 we know 3, A2 unknown, S2 we have found out it is 4. Therefore, A2 equal to 4 minus 3. Thus, second term is what? 1. Okay, first term is 3. First term is nothing but this one. Therefore, first term is 3. Next, to get the second, we know the symbolic notation of S2. A1 plus A2 equal to S2. By substituting the value of A1, S2, here we got A2. Nothing but second term. And the third term. What is the third term? Third term is also and A1 plus A2 plus A3. If we put like this, S3, then again by using that Sn notation, we have to get S3. But here, children, that is not necessary. Okay, then how shall we, instead of this one, now we shall take what? d equal to, let us get d, a2 minus a1. Since we know a2 is 1 minus a1 is 3, thus d is what? Minus 2. Once we know what d and a1 is nothing but what, children? It is a. Then, okay, you know it. We can get any term. That means now getting third term or 10th term or nth term is not at all a difficult one. Now therefore, third term, a3 equal to what? A plus 2d. A is what? A is 3 plus 2 into d is minus 2. So thus 3 minus 4, hence it gives what? Minus 1. So therefore third term we got as what? Minus 1. Next 10th term, a10 equal to, we know, a plus 90. Therefore, now we shall substitute the values of a and d. In general, we know 10th term is a plus 90. Okay, children. Now, therefore, what is a? A is 3 plus 9 into d. D minus 2. 9 into minus 2 is what? Minus 18. So, this gives minus 15. So, thus 10th term is minus 15. We are asked to find out. First we got, second we got that also, third is minus 1. Now we got 10th term, it is minus 15. And finally we have to get what? Nth term. And nth term, an in AP, general formula, a plus n minus 1 into d. When it is nth term means n is n itself. Okay, n is n. If it is 9th term, a9. If it is 10th term, a10. If it is n, it is an. A is 3 plus n is n minus 1 into d is what? D is minus 2. So therefore 3 minus 2 into n minus of minus plus 2. Thus 3 plus 2 is what? 5. 5 minus 2n. This is what? The nth term. Don't get confusion with Sn. Sn is what? 4n minus n square. In that particular AP, what is the nth term means? It is an equal to 5 minus 2n. Okay, children. Now, the second, find the sum of the first 1000 positive integers. In this case, children, we know that let S equal to nothing but sum of the first 1000 positive integer. It starts from 1 and the second term is what? 2. Means it differs. Each successive term is obtained by adding 1 to the preceding. Finally, here up to 1000. So this is what? The sum of first 1000 positive integers. How to get that sum? Which will be the suitable formula? Whether it is ADSN or ANSN, and already we have derived one more. Do you remember that? Sn equal to n into n plus 1 by 2. Whenever, wherever the common difference comes 1, we shall prefer that one, children. Which is that formula? We know that here we know that Sn equal to n into n plus 1 by 2. When this can be applicable means whenever in an AP, if the common difference is 1, then easily we can apply this. Okay. Here also the common difference is 1. And very important, one more condition is this. To apply this, in case of this formula, Sn means it starts from 1 and common difference is 1, ends with n. Okay. Now here just look at this. It starts from 1, common difference is 1 and ends with 1000. Therefore here that n is nothing but what? 1000. Hence children here S1000 means what? What does this mean here? Sum of first 1000 positive integers. That's only one unknown and that is 1000. And keep in mind once again, it should start from 1, common difference 1, and if it ends with n, then we write this. Therefore here, just it resembles the same. Starts with 1, common difference 1, ends with 1000. That's why S1000 equal to 1000 into 1000 plus 1 divided by 2. Hence 500 into 1001. Therefore 5 ones are 5 into 0, 5 into 0, then 5 ones are 2 more zeros. So therefore sum of what? The first 1000 positive integer is what? 500, 500. The third sum, find the sum of the first 40 positive integers divisible by 6. This is little different from the previous children. Previous stopped there only, but sum of the first 40 positive integers like that. There we had 1000. But here one more extra condition is this, divisible by 6. So now therefore, let S equal to, so according to the condition, let S equal to find the sum of the first 40 positive integer. 40 positive integers. What is important condition? Divisible by 6. Therefore, which could be the first integer that should be divisible by what? 6. Means simple common sense, it is nothing but 6. Correct? Then just go on multiplying by what? 6 ones are, 6 twos are like that. Hence second is 6 twos are 12. 12 is divisible by 6. 6 threes are 18, etc. Then 6 into 40 means 240. This is what the meaning of the given statement. The sum of first 40 positive integers which are divisible by 6. Okay children. Now just you see, whenever the problem is divisible, multiple, in such cases we shall take that itself as the common factor. Okay, here which is the common? 6. Let us take that. Hence then we get 1 plus 2 plus 3 plus etc. plus 40. Now just here you observe, this is nothing but what? It starts from 1, common difference 1, ends with 40 means here we can use the symbol as what? S40. What is that S40 means? Here it is understood, starts from 1, common difference 1, ends with 40. Therefore, here we could apply the formula n into n plus 1 divided by 2. Just we mentioned that Sn equal to n into n plus 1 divided by 2. Not always when the condition obeys. Means what? It should be the sum of first n positive integers, since here we have the same. That's why that could be. Okay. Now, 1s are 3s are 3 into 40, 120 into 41 equal to, come to the rough one, 120 into 41. 1 into 0, 1 into 2, 1 into 1. 4 into 0, 4 into 2, 4 into 1, 4. 0, 2, 9, 4. So thus the sum of first 40 positive integer which are divisible by 6 is 4920. Now here in the fourth, find the sum of the first 15 multiples of 8. Let us take this as S stands for sum. First 15 multiples of 8. Therefore, the first multiple of 8 is 8 ones are 8 plus 8 twos are 16, 24, etc. What will be the 15 multiple of 8? Yes, it is 120. In the previous problem, I told you, whenever the problem is on multiple divisible, we shall take that itself as the common factor. Now, therefore, children, here the common factor is what? Yes, it is 8. 8 ones are, 8 twos are, 8 threes are, etc. plus 8 15s are. Now look at within the bracket, nothing but sum of first 15 what? Positive integers. Therefore, 8 into the symbolic notation of this is S15. Therefore, 8 into 15 into 15 plus 1 divided by what? 2. How comes this? In case of not always children, for any S15, no. That S15 should what? Start from 1, common difference 1, and if it ends with 50, then we know. Therefore, here S15 stands for what? The sum of first 50 positive integers. Only in such cases we could apply this formula. Sn equal to n into n plus 1 by 2. We have to justify that. How it comes? Therefore, 1s are 2 1s are 2 4s are 4 15s are 60 into 15 plus 1 16. Therefore, 6 6 are 36. 6 1s are plus 3. Then 0. Thus the sum of first 15 multiples of 8 is this. Fifth sum is the sum of first n odd numbers. Hence, we shall take the sum as what, children? Yes. Let S equal to sum of first n odd. Therefore, 1 plus 3 plus 5 plus etc. plus n. Okay. See here, common difference 2, 2, 2, etc. Therefore, put semicolon. Forms means this list of number forms an AP with CD. How much it is? 3 minus 1 etc. means 2. Okay. Now therefore, A is 1, D is 2, N is N, and we need sum of N terms, that is Sn. Okay. The general formula, we know that. What do you know? Sn equal to n by 2 into 2a plus n minus 1 into d. Therefore, Sn, because n is n itself, n by 2 into 2 into 1 plus n itself, d, it is 2, thus n by 2 into 2 plus 2 into n, 2 into 1 get cancelled. Therefore, n by 2. This is what? N by 2 into 2n. Then 2 get cancelled. N into n is n square. Thus, Sn equal to what? N square. Here, you have to observe one thing. What is that? Sum of n odd numbers. Therefore, we can take this itself as a formula for what? Only for sum of first n odd integer. Look at this, children. If it starts from 1 and the common difference is 1, that means nothing but what? Odd numbers. If it is nothing but odd positive integers, then instead of using this, even we could use this one. Sn equal to n square. Today's home assignment, children. Find the sum of first n even positive integers. Next, this is of course quite interesting, just you try. Find the sum of the odd numbers between 0 and 50. Here, between means we have to exclude that. Excluding 0 and 50. That means here s equal to 1 plus 3 plus etc. plus 49. We'll continue the next class. Thank you.